Okay, so today we're going to do the tide problem. It's kind of a cool application of trigonometry. What is it? 1, 3, 22. Okay. So our objective really is to use trig graphs to model a real life problem. So maybe you guys may never do this, but this kind of math is used a lot. Ethan, you might use this someday. Sine curves, sine waves, right? You might. Yeah, well, I don't know if you'll do a tide one, but you'll do, huh? Yeah.
Pressure's on.
Pressure's on. So I made a really kind of a fun problem, but it's a good illustration. Okay, so one sunny day, Bill and Landon were sitting on a pier watching the tide come in. On this day, the high tide was at 1 o'clock a.m. with a height of 5 feet, and at 9:30 a.m. the tide was at its lowest at -1 feet. So a negative tide is possible, just means the tide's out just a little bit further, 1 foot in depth, just a little further. Okay. So what I would do is I'd start by at least making a couple of points. So, you know, I'd put a point at. So I'm going to make this 1, 2, 3, 4, 5 feet, -1. And now my axes are going to be in terms of time. So 1 hour. So I got my 1, 2, 3, 4, 5, 6. Here's 6 a.m. 7, 8, 9, 10, 11, 12. 12. Noon. And then we're going to stick with military time, okay? Noon. So we're going to go with a 24-hour clock, so 12, 13, 14, 15, 16, 17, 18, because you have to stick with a 24-hour clock. It wouldn't make any sense if you called that 6 again, right? 19, 20, 21, 22, 23, 24, okay? So there's midnight again, okay? All right, so I'm going to put an indicator at high tide. There's my high tide. And at 9:30, 6, 7, 8, 9, 30. Right there. There's my low tide, okay? And I can even connect the dots. And it is curvy. It is a curve. We know it's going to have the shape. Okay, I can do that. How am I doing?
Does it need to go through 8?
I don't know. I don't know exactly.
Does it not really matter? It just needs to go from 5 to -1.
Yeah, at 9:30, yeah, from 1 o'clock to, and then, Carly, I don't know, I mean, I can put it on a calculator, which I will. I'll put it on a calculator and I'll get a much better fit. I'm just freehanding it now. Does that make sense? I do know it's going to be curvy, it's not straight, because it's going to be a sine or a cosine curve. Now, first thing I want to ask myself is, what is the length of this in time? So in time, what's the length of, I'm going to call it a half tide, okay? So what's the length of my half tide? From here to here, what's my time? So probably what, 8.5 hours? So if I go from 1 o'clock a.m. to 9:30, are we okay with that? So the length of half tide, right? So what I'm trying to do now is find the period. I'm really trying to gather the period because the period is the width of one tide, right? From high tide to high tide. So I'm really looking for the period. So I know that, yeah, from here to here is high to low, and then we'll go from low to high, and we'll get, yeah, 17 is going to be the period. You guys agree with that? 17 is going to be the period. 8.5, and another 8.5 to go from low to high. Okay? Right? So let's do that. Okay. So then we're going to add another 8.5, which makes a total of 17. Okay, so I agree. My period is 17. Thumbs up on that? Does that make sense? Okay, good. That's really important in this problem to know that. So the next high tide, to get the next high tide, I'm going to take my low tide, and I'll add 8.5 hours. To get the next high tide, visually, we're going to go from here, and we're going to go another 8.5 hours, right? So there's half, there's 1, 2, 3, 4, 5, 6, 7, 8. Should be at 6 o'clock in the evening, or 1800, okay? So if I were to take, mathematically, my low tide, which was at 8.5 time-wise, right? No, it's 9.5, my bad. Low tide is, the time is 9:30. 9:30 plus 8.5, let's see, 17, 18 hours, 18 o'clock or 6 o'clock p.m. Either one. Military time or 12-hour clock time. All right. Hi, I'm going to show it again, okay? This is 9:30, right? That's 9:30. 9:30, and I'm going to go 1, 2, 3, 4, 5, 6, 7, 8.5 is right. So at 1800 military or 6 o'clock p.m. is my next high tide. Thumbs up, everybody? Okay, good. Okay, so right here I'm going to put my next dot. And Carly, I'm just going to connect it again because I know it keeps going and going and going and going. How's that, Carly? You all right with that? Beautiful, right? So, make an equation. Is it a water slide or is it a roller coaster? I call it a water slide too, which is a cosine, right? So I'm going to start with an equation. I'll start with y equals cosine. Let's just start there, okay? Now, the amplitude is max minus min divided by 2. That's the easiest way. Or you can just find the middle of the curve, right? Pretty sure it's 3, I think. Yeah, it's 3. You know, the average. So the amplitude is going to be 3. Max, the highest high is 5, minus the min, which is a negative 1, over 2, 6 over 2, which is 3. Or you can kind of see it. You know, from height of 5 to negative 1, height of 5 to negative 1, right? 6, span of 6, the middle is 3. We're going to do. Okay? Now, we need to find the frequency, okay? So we need to find B, which is the frequency, which is 2 pi divided by the width. We know what the width is, don't we? The width is 17, right? Didn't we say the width is 17? So my frequency is going to be 2 pi over 17. Now I'm going to change this to a decimal just because it's going to make it easier, okay? You all right with that? What is it? 0.36. Okay, so I'm going to write my 0.36 here. T. T for time. You okay with T for time instead of X? T for time. Now, my roller coaster, no, my water slide, sorry, forgive me. My water slide started here at 1, didn't it? So if we pull it back, we've got to bring it back. So we have to subtract 1, or remember it's the opposite, right? So if we pull it back to here, we subtract 1. So it's got a horizontal shift of 1. So we'll go T minus 1. T minus 1. And the entire curve has moved up to 2. I mean, the middle of the curve, and if you're not sure how to get it, I'll show you here real quickly. The middle of the curve is right there. Do you see it? It's the middle of the curve. So it's been moved up 2. Can you see the move up 2? Now, if you can't see that, there's a formula also to use. If you can't find the value k, which is the vertical shift, k is equal to your minimum plus your amplitude. Our minimum is negative 1, min. And our amplitude is 3, so the value of k is 2. So here is our equation. That's our equation. Now we can graph this. We can graph it, okay? So to graph this, I'm going to do several things to graph this, okay? So first thing I'm going to do is make sure I'm in radian mode, right? Mode, why does it have to be in radians?
That's pi.
Yes. Yes. So radian mode, okay, and then I'm going to go y equals, clear this, I'm going to go my 3 cosine 0.36. Now, observe. The calculator put it parentheses right there, didn't it? See that? So I'm going to need another parentheses for this one. You okay with that? I need another parentheses for that one. So I'm going to go parentheses x subtract 1 parentheses. I'm going to go double parentheses. Can you close the whole thing? Okay, double parentheses. So I'm really putting it in like this. And then plus 2. Now before I graph it, I better fix my window. Okay, because my window of my calculator needs to fit the window of this graph. Okay, you really should. So I go to my window. Am I going too fast? Okay, am I right? Tanya? Okay. So I go to my window, and I've already got it kind of 0 to 2. I've got to go 0 to what? How about 24? At least 24, right? 24 hours, right? Scales by 1 hour. You okay with the scales by 1? Minimum and -2 probably. I don't need to go -5. Height of probably, let's go 6. So I'm going a little bit above, a little bit below to see it, correct? And now let's graph it, see what happens. Okay, let's see if we did a good job. So I'll go to graph, and there it is. Looks like what I have, correct? Thumbs up. Now, turn the page. Good. Now, if there's a boat moored at the pier with a 2-foot keel, at what times would the boat need to be out at sea? Now, this is a true story. It was New Year's Day. Now, come on now. It was New Year's Day. Len and I got up early because Len and I did not party that night. We went to bed about 10, right? Of course, Len was probably 10 at the time, so of course he didn't party. We got up, we took a walk, we went down to the Freeland dock, and there was this expensive sailboat laying on the beach, the dock pinning the keel down. There was water sloshing in it. So what happened is in the middle of the night, when they were up partying, having a good time for New Year's Eve, the tide went out, and the boat slipped under the dock, because it's a floating dock, does that make sense? Mm-hmm. Pinned the boat. All water rushed into the boat, right? And then as the tide started coming back in, the boat's pinned under the dock, right? All of the water comes back in. This is like a $500,000 sailboat ruined because they didn't think about the tide. So if I want to find out, if I do a y equals a second one, y equals 2. Y equals 2. So if y equals 2 is my 2-foot keel. Does that make sense? And if I graph this, it shows me when my boat better get out to sea. Okay, so right up here is plenty deep, right? Right up here is plenty deep. Of course, I gotta sink. Right in here, we're in trouble, right? The keel's going to hit right about there. The boat's going to start to list. Negative tide here. It's going to be on its belly. Okay, and then here we can have the boat in. It's okay to say the keel's going to fit. Okay, so to find out when we better take it out, I'm going to go and use my trace button or my intersect button. My intersect button's easier, but I'll go to my trace button. It's a bad time, okay? So right about there, at about 5:30 a.m., you better get your boat out. See the 5.36? So about 5:30, I'd say at about 5:30 a.m., get your boat out, otherwise you're in trouble. And then let's see when you can take your boat back into shore. About 1400, about 2 o'clock, at 2, about 1400, or that's the same thing as 2 o'clock p.m. During these times, you better have your boat out in the bay. If not, your boat's going to get ruined, okay? How's that? Okay, so just two problems, no, yeah, two problems. No, let's make that, we'll do it 17 together, okay? All right, we got time, so let's try and work on this. If you guys need a mass break real quick, I'm not gonna do any work outside, obviously.